Hello and welcome back to Room Lasagne. Next speaker will be Jens Smit, which will speak us about deploying on Amazon. Jens?
All right, thank you. Welcome everybody. This will be sort of a case study about how we at Layar are using Python to build our service, basically our augmented reality service. This will not be a talk about doing augmented reality with Python. Sorry. For those of you who were hoping that, I hope not. So, Layar, come on. I hate preview. So, yes? Cool. So, Layar is an augmented reality company. We do mobile augmented reality. We're based out of Amsterdam. We have two quite different mobile apps, both related to augmented reality. And we use a lot of Python in the backend, so all our server side, basically almost every component has some or a lot of Python in it. The mobile clients are basically all either Java and native code or Objective-C and native code. So this is a story about the backend. So the Layar app, it's the same name as the company. Management summary, Terminator vision for Android and iOS. What we do with the app is we give you the camera feed of your phone. We try to determine where you are or what it is that you're looking at, and then give you extra information about either your location or whatever it is that you're viewing. So for instance, if you're in location-based mode, you could see ATMs in the neighborhood, houses for sale, what people have tweeted around you, photos from Flickr, Panoramia, whatever basically it is that you're looking for. We have a lot of very localized content for Layar, festivals, treasure hunts in cities, promotional actions, and we support quite a lot of features like buttons to websites or to directly call text, 3D models, video, audio. And it's an open platform. Basically, everybody can create content for it through our specifications. Available Android and iOS. We also had Symbian and BlackBerry versions, but we've basically quit those because Symbian and BlackBerry aren't going anywhere. Our second app is called Stick2. What is Stick2? Stick2 is a bit of an experiment of ours. We like to call it digital gravity and augmented reality. You can see a screenshot here. Basically, you can take a picture of anything, though flat surfaces work best. Magazines, road signs, posters. You can draw on it. You can place stickers and motifs. Basically, go all out and then publish it, share it with the world, and everybody else that takes a picture with Stick2 of whatever it is that you've posted on sees what you've created in context, aligned with the picture. You can like stuff, you can comment on stuff. It's been launched globally only a couple of weeks ago. We used to have a local beta in some countries. It's really an experiment into the social aspects of augmented reality, and it's a major R&D driver for us. So, two apps with a totally different look and quite a different offering one backend. So why do we have that? We're really reusing the same core technology. So that's the image recognition and visual search. So finding images in a large database of images you've already seen before. But service models are really different. Layar is an open platform and has always been like that. There's documentation online how you can create augmented reality content for Layar for others to find and use. We also have our own authoring tool called Layar Creator, which is a very simple web service. For instance, if you have a brochure that you want to put augmented reality buttons on, you just upload the PDF, you drag and drop some images, you say publish, and it's live. If you dive into the API, which is basically a JSON specification, plus some web service conventions, what your service should look like if the client is coming to you for content, you can do a lot more like animation and time triggers, text, audio, geofencing. But yeah, so some of the content for Layar is hosted by us, which is part of our whole backend system. Others is hosted by third parties, and we basically just relay to them. Stick2, on the other hand, is a completely closed service. We control the clients, we control the server, internal protocol, and all the content is generated by users using the app. It's its own ecosystem. So, what does the server side basically look like? Left-hand side is the most common entry point for clients, web browsers, everything. Everything is basically on AWS, as the title of the talk already suggested. We use a load balancer, and almost all requests go directly to our website or our API server, which is combined into one Django installation. It's a pretty big one. It's scalable. It's default running on 2 instances, but it can go up. We have a big database. We have a mandatory cache. We store metrics. We do centralized logging outside of the website app. We have a visual search engine. Blog is pretty big. I'll explain why in a moment. We have a specialized service for running long jobs. Storage is done in S3 mostly, except for the visual search engine. There's a lot of smaller components missing from this diagram, but when I tried to put everything in, it didn't even fit in my screen on high resolution. So I've left them out because they're not that interesting. So the web-facing side is Django, and I've seen a lot of talks on other web frameworks, TurboGears or Flask. I still think, despite what I've seen, that Django is generally a good idea for a generic web service. It has a very nice feature set, a solid, if somewhat limited ORM, free admin interface, and I found that it's really usable for building both very good-looking websites, web pages, and very lean APIs. As an active development community, you can find all sorts of stuff to enhance your Django. And for those that say that Django is too heavy, there was a talk Monday morning, Christoph Pettis, basically giving you a lot of tips and pointers about how to optimize your Django app, Django installation for high loads. And you can go to 20K requests per second on a Django installation, and that's not the limit. So if you think Django is too heavy, get the video of his talk or go to his blog. You can get a lot of performance out of Django. Yeah, that basically handles most of what we do. Either it front ends for it, or it does a lot of storage of users. Our content catalog, our website itself, so that we may be decoupling that later, and yeah, delivering all the content that we're hosting ourselves, or relaying for the content that's hosted by third parties. So all our files are stored on S3, which is Amazon's object storage. It's very reliable. It's quite slow. So when you're building your app or your web application on Amazon, take that into account. Database is MySQL. It's not the best choice for Django, but it is the easiest choice when you're on Amazon. You can do Postgres on Amazon perfectly fine, but then you have to set up your whole Postgres installation yourself, maintain it yourself. If you take the Amazon RDS offering, it's just a database in a box with hardware failover, with read replication built in. Saves you a lot of time if you let it. Amazon do the heavy lifting. So by default, if it's not so busy, we have two Django boxes running side by side. One is generally not enough even on slow hours, plus you want to stay available if something happens to one of the boxes. Running behind a standard AWS load balancer does the job pretty well. Has some quirks, but you'll find them out on the internet. Basically, the most annoying thing about AWS load balancers is that they cut the connection if there hasn't been a response in something like 30 or 60 seconds. But you don't want long polling calls anyway to your Django app because it takes up your worker threads for your web server. We autoscale when load goes up. We recently launched a new version of our product. Got a lot of coverage on some tech blogs, even CNN, I think. We quickly scaled up to 10 instances when the load grew, and we stayed at that for like 2 days, and then we generally declined again. Popular data stored in Memcache. You should really do this from the start. Whenever you're building something, think, is this going to be requested a lot? Yes, store it in cache. Don't wait. Scaling the database is a bit harder because you don't just want to duplicate your data. Nice thing about AWS is that you can just request a bigger machine for your database up to a certain limit. If you have the biggest machine, you can't get any bigger. Or you can enable read replicas, and then you'll have to do some database routing in your Django installation to pull multiple databases to round robin or something smarter. Yeah, logging. Logging is important. If your application is doing something that it's not supposed to do, and it will, nobody is a perfect coder, you need to find out how and why. With Amazon, especially with autoscaling, instances come and go. Their volumes are destroyed at the moment that the machine is terminated. So you need to log your stuff elsewhere or it's gone before you know it. We use Sentry. I think it's very good. It gives you almost free grouping and counting of similar messages. It can give you priority. You can filter on tags or logger names. You can have a lot of different machines or different services even logged to the same Sentry instance, and you can separate it into what they call projects. So you have a dashboard and you see activity for each project. So if you see a spike on some of your backend servers, you know that there's something going on there. You go in there, you look at the log. It's built by David Kramer from Discuss. Probably he had some help as well, but he's the main publisher on GitHub. Many thanks to him. It's a really cool product. It's available open source. Look at it if you don't already have it. So the visual search engine. This is a major part of what we're doing right now. Whenever you take a picture using your phone with Layar or Stick2, we try to recognize whatever is in that image. If it's a Google logo or a page in a magazine or a road sign, whatever. We try to check if we've seen it before. The technology itself comes from Kachum. It's a Telefonica spin-off. we did a bit of screening of available offerings, and theirs came out on top. So we've been using it for over a year now. It's implemented in C++, compiled with as much optimizations as possible on the machines that are running them, because speed is very important. Visual search query can take something like 2-3 seconds. Shorter is better, longer will kill you in the end. So for handling the requests, all the networking, we use Tornado. We use Boost Python to directly link to the C++ or interface to the C++ binaries. No IPC or as little as possible. And one thing about databases where you especially optimized for search is that your search time will grow with your data set. So currently what we consider acceptable is 60,000 images on one server. So we heavily shard our reference images across multiple servers. So whenever the pool grows too big, we launch more instances. We redistribute our reference image set, which can take a couple of hours. We switch over the URLs from the old search engine to the new search engine boxes, and then we disable the old search engine boxes. All pretty easy with Amazon, just bringing machines up and down. All the machines are also redundant, both for high availability and read speed. If we see a large increase in search queries, but not in storage queries for new images, we can decide to always scale out even more replicas of the same shard for even better read speeds, round-robin distribution. Their storage is on EBS volumes, so that's Amazon's offering for basically volume-based storage, almost like regular disks. It's more expensive than S3. It's also a lot faster because it's basically direct network I/O to a SAN instead of S3, which is HTTP based. Yeah, analytics. So we try to track what's going on our servers. If we have what kind of increase in user base we have, what the users are doing. Are they searching for a lot of content? Are they finding a lot of content? Stuff like that. So we log a lot about what's happening in our apps. Yeah, we basically ended up rolling something ourselves a little while ago. It's a separate MySQL RDS on Amazon with a lot of storage in it. We log data points to it. They get written to tables. There's a few tables for different sorts of data points. We have a small Django app where you basically give it a storage SQL query for aggregation, so rolling up into hourly or daily bins. Get executed frequently. Results are stored in another table, and then there's yet more SQL stored in the app to get data out and feed it to HighCharts, which is a JavaScript library for charts. Looks really neat. This is sort of a legacy solution caused by people deciding, hey, we know SQL, we really like it, so we're going to build this in SQL. This was not a good idea. It works for now, but this does not scale. It really does not scale, not over time, not when your user base increases. So if you're about to start something like analytics or analyzing what your users are doing, use something else. Graphite, TSDB. If you're really into rolling your own, do something on top of MongoDB. Don't do this. Long-running jobs. We already saw it briefly in the architecture overview. We have a few very specific tasks related mainly to image recognition. Those are things that even on good hardware can run for 20, 30, 40 seconds. You really, really, really don't want to do that on your web app, even though that's the entry point for the images being uploaded. So we built a very small thing ourselves. We've called it Spencer. Everybody has any idea what the reference is, come to me after the talk. And that's basically a twisted loop that gets a job ticket from SQS. SQS is Amazon's queuing service. It's basically a queue with delivery guarantees, and you don't have to manage anything yourself because it just works. In the ticket, there's a job type, so either PDF, image extraction from PDF or image pre-processing for client-side image recognition. Some other stuff as well. Some arguments for the job. Usually that's the file stored somewhere, and a callback URL to be called whenever the job is finished. So Spencer starts a worker for the job. That launches a separate process. In our cases, it's usually binary code because, like I said, these are compute-intensive jobs, and binary and optimized code is usually just the fastest solution. That does all the hard work. The worker just kickbacks, relaxes, asks to be called back when the process finishes, and just returns to the main twisted loop. So that's available again for getting more tickets and launching more workers. And finally, when the process completes, worker gets a callback, stores the results, usually in S3, and then calls the callback URL, which is basically the website again, but sometimes outside of the ELB to not let it take up web-facing web threads. And yeah, so did I have anything more on this? Yeah, so we do multiprocessing. That's way easier to use all your cores than multi-threading. You don't have any global interpreter lock issues with this. So if you're on 4 cores or 8 cores or 16 cores, just configure the amount of workers, and it just works. This scales massively. So a little while ago, we got 50,000 reference images at once. If you figure out that most of them take 30 seconds to complete, you've got a lot of work ahead of you. We scaled up to some 20 workers in parallel without a hitch. Again, this is Amazon. You say, okay, give me 19 more like these, and you're there. Yeah, calling separate programs makes it really, really easy to use whatever is available. You don't need to link. You don't need to interface. It's command line arguments, and there you are. And I did a line count. It's some 3,000 lines on top of Twisted. It's still very alpha or in-house. It's still very specific to AWS with SQS and S3, but you could extract that away. I don't know if anyone thinks they have an interest in this. If they are, let me know. We're thinking about making it open source, but it's nice to know that it's of interest to someone. So, some things about AWS, as promised in the introduction of the talk. AWS provides a lot of convenient services, databases at a mouse click, machines, queuing, monitoring. You only pay for what you use, so it's very startup friendly, which is was a major selling point for us. It has a web interface for configuration and more monitoring and trying everything out. It's fully automatable through command line tools. Yeah. They're not brilliant though, the command line tools. You have to get used to them. They're written in Java and they have a really weird interface, but there's also Python libraries to make your life easier. But AWS, lots and lots of marketing text. Sorry, don't get scared away by it. It's a very American company whenever you search for something, first thing you find is all the benefits, how it's so cheap, and then you look down and you see the price and you think that's not really cheap. It is definitely not the most economical solution if you're if you're looking for compute power or cheap bytes or whatever. AWS is not the way to go, but it's very easy to start small and build out. It's also very, very easy, we found, to launch instances and keep launching instances and launch a database and launch another database just to test something out. Clean up, really clean up after you're done, because having a lot of databases running in parallel just adds up. Databases are very expensive at Amazon. Another thing, assume no guarantees at all. Instances get zapped sometimes, not all the time, but once in a week or once in 2 weeks, an instance will just magically die in the middle of what it's doing. It happens. Make sure you have transactions or journal logs around anything that's important to complete successfully or either fail completely. Have auto-scaling groups detailing your minimum amount of live instances you want. And also backup outside of Amazon. Because everything on their side we've seen fail. Lightning strikes in Dublin, in North Virginia, generators failing, cleanup scripts not completing, and therefore flagging in-use blocks on RAID arrays as not in use. We've all seen it happen. Your data, and you can just take your bike and ride to the co-location, because nobody at Amazon even knows which rack your machine is in, which rack your disk is in. And by the time they found out, it's been reused 4 or 5 times by different customers. So if everything you value, set something up to get it out at semi-regular intervals, and also use their internal snapshotting for backups. So this is not a scare talk. This is just be aware that they don't promise, or at least they gave some guarantees, but even for them it's difficult to stick to them, we found. And working in the cloud, even working completely in the cloud, we don't even have any local infrastructure. Our testing is done on AWS. Our development is done on our own machines. Our production environment is completely in AWS. At the office we have or 2, I must say, internet connections, and that is our own IT infrastructure. But that does not excuse you from having operations. These machines on Amazon, they're not physical, or at least not in the sense that you're used to, but they still need tuning, cleaning, configuring, everything from monitoring, log rotate, give them then a hug in the middle of the night if they're sad and gone down. Yeah. Get someone for operations, even though they may be hard to find. It really saves you a lot of headaches. Yeah, some sort of tips and tricks. Yeah, we use the right tool for the right job. Python has a lot to offer, so we're using Django, Twisted, Tornado. Some stuff we rolled ourselves on top of that. We've also once used MySQL for something that it really was not appropriate for. Pick the right tool for the right job. Even if the easy solution is to pick something you know, you'll regret it. If you're lucky, in 1 week, when you still have time to revert. If you're not lucky, you're 3 months in and you're stuck with it because you need to deliver in another month. Automate your deployment. Fabric, Chef, Puppet, Juju for all I care. Invest in that early on. It makes your life easier. Deploy early and do dark tests. So if you have some new feature, test it on your test environment first, of course. Disable it using feature switches like Waffle or Gargoyle, or at least those are two most popular. Yeah, test with a small group if features are working. So switch them on briefly, test for 15 minutes, switch them back off. So whenever it's deployment day and your management team or whoever has made a big announcement, you're not scrambling to get all the code updates to the server and migrate the database. You're already there. You just flip the switch. In your Django, for speed, offload anything that looks like work. So storing data to S3 is a lot of work, and usually almost never fails. So if you've received an image from a user, you can almost always safely assume that you will get it into S3 successfully. So just return to the user and offload to a worker thread or something outside of your WSGI. I've seen a lot of people advocating celery here. We use Django CTask, which is built on top of 0MQ. We found deployment is about 5 times as easy, and it's smaller, it's faster, and yeah, something that has bitten us, and I hope it won't bite you. Cache anything that you think is big or intensive from the beginning. So almost any time you do a database operation, think, is this data going to be popular, yes or no, or requested a lot? If so, make sure you store it in cache, and you always try to retrieve it from cache, because it will work in test without cache. Anything will work without cache. That's the whole idea. But as soon as you go to production and 25 or 2,500 people use it, it'll go down in flames, and you'll be sifting through your code base for any database heavy calls. That's no fun. So, looks like I've finished a bit earlier than sort of expected. So, I hope anyone has any difficult questions for me, or easy questions, or anything.
Hi. Did you have any problems with recently Amazon outage, power outage, and if so, what is your recommendations how to prevent from such situations in future? Maybe use another cloud storage service, or just
yeah, so I think that mic wasn't working properly, or was it? So the question was, anyway, if we had any trouble with recent outages with Amazon due to power failures. Yes, months ago there was a lightning strike in Dublin, in Ireland, that sent both the main power supply and the generators into a downward spiral. Lots of parts of the whole infrastructure got affected. We got hit too. The most common solution for that is, unfortunately, to throw more cache at it and set up almost all of your environment in 2 geographically separated zones. So, for instance, in Ireland and US East Coast or US West Coast or whatever. You'll have some trouble, especially setting up your database replication. But yeah, duplicating almost your entire environment across 2 completely separated geographic locations is the way to go at that. If not, at least try to use as much different availability zones within one region, because the availability zones are usually separated pretty well in terms of power supply and network. Over there.
Are you subscribed to this story?
Sorry, a little bit.
Striped your disks, or is that a risk you don't take?
No, let's see. No, we don't stripe our disks right now because almost everything that's really speed dependent is CPU bound. As far as risk go, I would totally do it. Right now we are not running on redundant disks anyway. For visual search, we have completely redundant environments. So if one volume fails, we always have the other one, and then we replicate back from that.
Okay. You told that. Okay. You told that using multi-process instead of multi-threading will help you to speed up.
Mm-hmm.
But on the Linux kernel, threads and process are, well, quite similar. So I'd like to know why and which were the problems on multi-thread implementation instead of your multi-process one. And another question about the analytic infrastructure. You told that it doesn't scale. Which was the bottleneck of the infrastructures, and how would you think to a way to redesign it, considering that even standard relational databases can be used as a simple key store value. So you may still preserve your server, but just using it in a different way.
Okay, so first one about multi-threading and multiprocessing and why it's easier to use all your cores when using multiprocessing, even though threads are and threads and processes in the Linux kernel are really similar. That's true, but the way that the CPython interpreter implements threads is that threads running concurrently still have to wait for the global lock of the interpreter. So it's really a Python specific thing. Aside from that, I basically think that thread programming is really messy, and it's a surefire way to introduce race conditions in your code, especially in situations where it's not needed.
Hi.
And no, sorry, he had another question about analytics and relational databases. Even though you can use a relational database as a key value store, there are other implementations that are specifically target at being a key value store. They're much faster, they're more efficient with disk space. So, and I'm not really that concerned about keeping my MySQL database just because I know MySQL well. I'd rather learn something new if it's a better solution for the job.
Yeah, I wanted to know what type of data are you caching, because I understand what you are doing is just taking the pictures and do all the visual recognition stuff. And I mean, each picture you will need to recognize it and all that part. So what type of things are you catching?
Okay, so the visual search results are not being cached for the pretty obvious reason that it's really difficult to cache based on an image that's effectively unique because it's being taken by a user with his camera phone. We also have, I've not really highlighted that in this talk, but we have a lot of service calls on the side, like user details, what's new, what's around me, and what's my favorite layers, what are my bookmarks and stuff like that. Those are very easily cacheable because they're very limited search queries.
What exactly happened with Celery? Seeing that you created the, what was it called, Spencer? Apparently, which seems to do something fairly similar.
Okay, so the way, with Celery, it's really easy to have a large code base. You have a function in that, and you say, okay, I want to split off this function as a task and execute it. This is basically a whole separate functionality. We try to keep it as small as possible, and we wanted to use SQS. We've had a lot of bad experiences with Celery. It's crapping out on itself. Yeah, we've worked with Celery quite a long time, both in the main app and elsewhere, and we decided that in the end we didn't really like it. And we're very happy with what we have now, so I think it was a good choice.
Anyone else? Sorry, I have a question.
Yeah.
You mentioned Gargoyle before.
Mm-hmm.
Even I use Gargoyle, but the only problem I have is that when we do like a new release, and we like to use these dark tests, which is like only administrators can see the new features. How do you handle like the migrations?
All right. So how do you handle your Django migrations with feature switches?
Exactly.
Basically, when you're doing a Django migration, because you're making a change to your ORM schema, it's a very good idea to do it in 2 steps. First, build the new change, write a migration that just, for instance, adds a column, deploy that, run with that, and at a later stage, write the second migration that deletes the old column. For instance, if you're renaming or reusing columns. You're running with duplicate data for a short amount of time. It's a denormalized database, but it's a very conscious choice, and you know that it's a temporary situation. Also, making your migrations as atomic as possible. I imagine you're using South for that.
Yes.
Making your migrations as atomic as possible makes it a lot easier to migrate back and forth if you ever need to. So if you have like 3 additions and 2 renames in one migration, chances are pretty good that there is no going back. If you first do like 3 additions and then at a later stage do 3 removals for the old columns, it's much easier to go back and forth if anything should turn out to be not the way you wanted it to be.
I understand. It's a very good tip. So you are suggesting to do first any type of change which does not destroy the old version.
Yeah, does not affect any of your existing infrastructure.
And then when you go in production, in actual production with the new version, you can do the other migrations.
Yeah, so first you do one deployment with the dark tests. If everything works, you flip the switch, or you just remove the switches so you run on the new code. And only then you do the migration that throws out the old data. And at a later stage deploy that. Basically, at that point, throwing out something you're already not using anymore, so that should not affect anything.
All right, thank you very much. Anyone else? Okay, let's thank you our guest.
Thank you very much.
Thank you very much.
Yeah, thanks.
I hope I entertained you too.
Well, I only saw the -30 actually.
The -3?
No, the -30.
But I tried to, I put other 2 like this, but I didn't.
I never saw anything. I looked at that monitor more.
Okay.